In winter, the smog over an Indian highway is an overwhelming physical presence. This haze traces directly to the exhaust pipes of millions of engines. To curb these emissions, the government of India relies on a strict set of mathematical limits that dictate exactly how much pollution a tailpipe can legally release into the atmosphere. These are the Bharat Stage emission standards, established by the Central Pollution Control Board and the Ministry of Environment. They apply specific caps to the output of air pollutants from both compression-ignition diesel engines and spark-ignition petrol engines. These norms operate as a hard, mandatory threshold. If a vehicle's engine cannot meet these precise chemical outputs, it cannot be manufactured, sold, or registered in India. India modeled its emission regulatory framework directly on European standards, adopting the Euro tiers as the blueprint for its own domestic requirements. The true roadmap took shape through the 2002 report led from the Shelker Committee. This became the National Auto Fuel Policy in 2003, charting a phased rollout of these standards across Indian cities. Unpacking the current state of Indian emissions requires looking at the actual numbers these policies mandated, the intense hardware and chemical redesigns required to hit them, and the systemic loopholes that keep the air dirty. The transition to BS6 represents the single largest chemical policy shift in the country's modern industrial history, demanding a total overhaul of automotive engineering. The timeline shows a steady initial progression from India 2000 through Bharat Stage 4, but in 2016, with air quality degrading rapidly, the government made a drastic intervention, canceling the planned Bharat Stage 5 phase entirely. The crisis in Delhi forced the Petroleum Ministry to introduce ultra-clean BS6 fuels in the capital region ahead of schedule, starting in April 2018. This culminated in a final nationwide mandate. Starting April 1, 2020, every new vehicle sold and registered in India had to comply with Bharat Stage 6. By skipping a regulatory generation, the Indian auto industry had to design and implement exhaust technologies in 3 years that took Europe nearly a decade. Comparing raw data limits shows the severity of the jump. For petrol vehicles, nitrogen oxide limits were cut from 80 milligrams down to 60. Diesel faced an aggressive 70% reduction. Both fuels now share strict 4.5 milligram caps on particulate matter. These numerical limits effectively mandated the abandonment of older, dirty diesel architectures, as they were physically incapable of hitting such low emission targets. To meet those strict thresholds, engineers had to redesign the fuel injection and exhaust flow from the ground up. For petrol engines, this meant replacing carburetors with programmed fuel injectors and installing robust 3-way catalytic converters to scrub harmful gases. These components are overseen by mandatory onboard diagnostics, providing continuous digital monitoring to ensure emission controls function correctly. Diesel requirements were even more complex. To hit soot reduction targets, automakers installed diesel particulate filters, physically trapping microscopic particles. Meeting the new NOx limits required selective catalytic reduction systems, chemically breaking down nitrogen oxides into harmless elements. The modern BS6 exhaust assembly functions as a highly calibrated, miniaturized chemical processing plant, operating beneath the vehicle in real time. Advanced catalytic converters are highly sensitive. They will instantly clog and fail if they are fueled with high-sulfur petrol or diesel. Table 19 highlights the necessary chemical shift. Under BS6, the maximum allowable sulfur content in Indian petrol was reduced to just 10 milligrams per kilogram. Diesel fuel quality underwent a similar transformation. From historical limits measuring in the hundreds of parts per million, sulfur levels were forced down to a matching 10 ppm threshold to make BS6 engines viable. These standards also extend beyond passenger cars, applying to agricultural tractors, construction machinery, and even thermal power plants. Executing the BS6 mandate required the entire Indian petroleum refining sector to overhaul its chemistry simultaneously with automakers to prevent the new engines from failing. Who actually drafts and enforces these technical engineering constraints across the country? The central nodal agency is the Ministry of Road Transport and Highways. 2 key groups handle the details: the CMVR Technical Standing Committee, which manages technical regulations, and the SCO, which coordinates implementation strategy. These committees rely on data from the Bureau of Indian Standards, which prepares the raw specifications that eventually become law. This organized paper bureaucracy provides the framework, But the messy reality of Indian roads presents a different set of challenges. The primary enforcement mechanism for vehicles on the road, the PUC testing centers, suffers from deep systemic failure due to a lack of training and uncalibrated equipment. A digital loophole on the official Parivan website allows vehicles with high emissions to pass. The site omits a mandatory CO-corrected formula, meaning many polluting cars are cleared during routine checks. Furthermore, while local pollutants are strictly capped, India currently lacks any mandatory CO2 emission standards for passenger vehicles. Then there is cycle beating. Manufacturers may optimize engines to pass gentle laboratory tests, while ignoring the far higher emissions generated during real-world heavy traffic driving. For example, European tests use an extra 100 kilograms of loading on the test equipment. To reflect actual road conditions in India, those tests really require an extra 150 kilograms. An engine tuned to pass a sterile laboratory test is ineffective if its emissions spike the moment it encounters a pothole in stop-and-go traffic. Moving from BS4 to BS6 in just 3 years was a genuine triumph of mechanical engineering and chemical refining. However, sophisticated hardware cannot solve an administrative crisis on its own. Clearing the air requires closing software loopholes, enforcing real-world driving emission checks, and providing actual oversight for the PUC infrastructure. India has mandated some of the cleanest engines in the world. Now it needs the institutional integrity to actually use them.